Hello.
Yes, I'm looking for sharing screen. So go to sharing screen.
Hello.
Now we will take another type of compressor, lobe type compressor, and that is called roots blower. So before going to roots blower, now reciprocating compressor ka topic khatam ho gaya. Now we are changing the topic now. So before that, I will share with you one GIF animation to show you how blower works. So roots blower, this is called as roots blower. Wait a minute, I think you're not watching it. I did not share it. Now you can see, hello, can you see this animation? Hello, students, can you see this animation? Anybody unmute mic?
Yes, sir.
Yes, sir.
No.
Yes,
Now mute your mic, please. Now you can see that there are two rotors. One is rotating, other is following it. So two rotors are moving, they have different centers and they have lobes. These rounded ends are called as lobes. And so this is how roots blower works. इसको lobe compressor भी कहते हैं, lobe type और roots blower भी इसका नाम है. यहाँ left hand side से intake होता है, यहाँ से discharge होता है. You can see there is no intake, there is no piston and cylinder, just a rotor with two ends rounded is rotating. So here is no valve, no stoppage. Here is discharge also, discharge side, no stoppage. So actually they just push, they do not compress at all. Inside the cylinder, compression process does not take place at all. So they just throw it from left side to right side. And when right side is open from this lobe, the right side is in the receiver. Receiver is high pressure side. So from high pressure side, air reverses back here. So and in this air thrown by the blower is mixed up irreversibly with the receiver air, which is coming from the receiver, flow back. So here it mixes up, and because of movement of blower, it is thrown inside. When it mixes up, its pressure increases, and with the help of continuous movement of this blowers, so air is gone to receiver. So this is how it works. So this is animated version, and now we'll go to other things. Now we'll go for analysis of power and efficiency of rotary lobe compressor. And again, I did not share. This I will share with you. So I am sharing this lecture note with you. Can you see it?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, now
Hello.
let me increase the view. Now you can see the enlarged view.
Yes, sir.
So now working up, this is all type of compressors was explained to you in my first lecture called classification. And those notes I'll send you, you can revise it again. I will not discuss how it works now. You've seen animation also, that should be enough. So this is the drawing. given in your book, figure 1222, roots blower with two lobe rotors. There are two lobes, one rotor is moving anti-clockwise, other is moving clockwise, because one rotor pushes another. So now every, see, 1/4 of a rotation, this position is repeated. So in one complete rotation, this volume is called V. Try to understand this first, then go ahead. So this V is pushed by this rotor. This rotor is two ends. One end of the lobe is here, one end is here. Now it is stretching to this side. Here is strap here. This is intake. Now in this position, behind this lobe and between the body and this blade, this rotor, a volume is strap. This volume is V. So this type of 4 volumes, every one complete rotation of shaft makes 4 times this intake volume, because one volume is taken by this, one volume is taken by this, in half rotation, and in full rotation 4 volumes of V taken. So Vs, our shaft volume, can be taken as 4V. V is defined here in this picture. So this is PV diagram. On the right side of this diagram, it is figure 1223. PV diagram is important. So intake is taken at P1 and discharge is done at P2. But what is this vertical line, broken line? This vertical broken line is constant volume process, isometric process of irreversible mixing of receiver backflow air and blower throwaway air. So when blower comes here, this air is thrown here, and from here receiver backward flow comes, which is at high pressure, and they get mixed up, and this pressure P1 becomes P2. So this is how it works. Inside compressor, nothing is done, no work. No work is done. Work is done only irreversibly in the mixing process of high pressure air and low pressure air from now in the PV diagram, the compression process is shown with broken vertical line. That means process is irreversible mixing of delivery gas and receiver gas at the constant volume. Volume V is volume of the gas trapped between one lobe and the casing when both ends of the lobe face its side of the casing. In one rotation of the shaft, 4V, volume is compressed from pressure P1 to P2. I think it's clear to you now. Now Vs are shaft volume is equal to 4 times V, and work done per rotation, it's not per cycle, work done per rotation. Work done per rotation is equal to P2 P1 multiplied by V. Sorry. This was per cycle. Then on PV diagram, this is correct. This was correct. So work done per cycle, P2 V2 from this PV diagram is 1 cycle, but such 4 cycles are completed in one complete rotation of the shaft. That's why work done per revolution or per rotation of the shaft is 4 times this work. That is 4 times P2 minus P1 multiplied by V, and this is equation 1227. Now volume dealt with per unit time. So, and in per unit time, for that we should know how much how much revolutions are done in 1 second. So that is N. N is number of revolutions per second. It is called as RPS also. So 4V, one rotation में 4V volume पंप होता है, तो N rotation में N से multiply करेंगे 4V N volume 1 second में circulate होगा. इसको हम कहते हैं shaft volume. Now power input is equal to shaft volume multiplied by delta P, that is P2 minus P1 multiplied by PS, and that is nothing but area of this diagram, this area. So this is the analysis of roots blower. We will continue it. How to calculate roots efficiency. So we have to derive this relationship. Actually, roots efficiency depends upon pressure ratio R. R here, small r is capital R is gas constant, small r is pressure ratio P2 upon P1. Gamma is the polytropic index Cp upon Cv. So this is the actually derived from this definition. Roots efficiency is good work done isentropically divide by actual work done. किसी भी compressor का machine का compressor machine का efficiency का ये formula है, work done isentropically which is minimum divided by actual work done which is more than minimum. So applying this formula we can derive this one. This we have to derive, and here is the start. So first of all, this is solution. First of all, we will define efficiency. Then actual power is equal to P2 minus P1 multiplied by Vs. We have just derived above. And in isentropic process in Thermo 1 we have learned, and in this reciprocating compressor also we have done gamma upon gamma minus 1 P1 multiplied by P2 upon P1 gamma minus. The only difference is this is polytropic process का जो formula था compression का उसको हमने gamma कर दिया, n को gamma कर दिया, तो वो हो जाएगा isentropic process. So after that we will go to put actual values of isentropic work divided by actual work. So after algebraic calculation we arrive at this, and we know gamma upon gamma minus 1 is equal to Cp upon Cr. So we replace with this, and finally we have proved this equation. So for Root's air blower, values of pressure ratio are usually 1.2, 1.6 or 2. And efficiency at lower the R, higher the efficiency. If R is equal to pressure ratio is 1.2, then efficiency is almost 95%. If pressure ratio is 1.6, by increasing, it is 84% efficiency. And if pressure ratio increases to 2, efficiency decreases and becomes 77 or 76.5%. So we can see that high pressure ratios efficiency decreases of Root's blower. So with this, we will go to now. We will finish, and our lecture is finished today. And tomorrow, inshallah, we'll continue at 12:25. Thank you very much.